with WMI objects, it is not uncommon to find that a particular device or resource that you're trying to get information for requires data from more than one WMI object. For example, when you look at your network adapters, you will likely find that there are a number of them in the machine. Some are hardware, some are software. Some are alive, some are not. Some are configured, some are not. When you retrieve the adapters using getWMI object, the collection of adapters that comes back may be in any order. It may not be in an order that you can recognize or sort out by their index position. If I wanted to find the IP addresses and which interfaces they were assigned to, I would need to use more than one WMI object. The reason is the IP address is stored in the network adapter configuration object, and yet the information about the specific adapters is stored in the network adapter object. When I retrieve the network adapter object, I'm going to get a collection of those. When I retrieve the network adapter configuration, I'm going to get a collection of those. The ordering of the objects in the two collections is not necessarily the same. So I need a way to find out which network adapter object in the collection goes with which configuration object in that collection. We have a way to do this. There is a method inside each WMI object called getRelated. The getRelated method will go into the object and find the related objects, the ones that are connected to this one, and give them back to you. If you run the getRelated method and give it no arguments, so you simply run getRelated parentheses, you'll get back a collection of all the related objects. If you run getRelated and give it the name of a specific class to get, it will go get that related object or collection of objects, if there's more than one that are specific to this original WMI object. Inside each WMI object is also a property called __class. In that property will be the class name for that object. So to find the objects that are related to one, you retrieve the object you want to start with, send it through a pipe to something like for each. % is an alias for the for each loop. And inside that loop, reach into each object that got retrieved, so each object in the original collection. Use getRelated to get a collection of related objects, and inside each one of those, reach in with the dot and pull out its class. So what that will do for you is give you a list of all the related classes for a starting class name. So here's a command that does this, and I've started with the Win32 disk drive object to see what objects are related to that. If we run that line, we will find that there are 6 objects that are related to the Win32 disk drive. You'll notice there are no blank lines except at the very end of the list. That means that there's one list of objects that belong to one disk drive. If I had more than one disk drive object, I would have multiple lists of related objects. If I wanted to prove that I only have the one disk drive, I could simply start by retrieving that, and I would see that I just have the one disk drive on this machine. When we look at the list of related objects here, we see a Win32 PNP entity, a Win32 physical media, 3 partition objects, and a computer system object. So if we wanted, we could ask for any of these by putting that class name inside the parentheses after our getRelated. So if I took my disk drive object, go and retrieve it again, grab its handle, reach inside and run getRelated, and specifically ask for Win32, let's say physical media. I could go get the physical media object that belongs to that disk drive. And there it is. There were 3 partitions showing. If I wanted, I could have retrieved the Win32 disk partition objects. If I do this, I should back a collection of all 3. And I did. And there's the partitioning objects. So we can use getRelated to get the related items. To use that data, unless it's a very simple case, you may have the issue that you have a number of objects to begin with, a collection of them, and then the related items for them may be also 1 or more objects for each starting object. So to summarize these or make them useful, a technique we can use is to start by getting the original collection. For clarity, I have made these separate commands on my slide, and at each stage assigned the data to a variable so that we can see what's happening as it happens. So once we have our original list of adapters, the next step to do is to filter them using a where object and get rid of the ones we don't want and keep the ones we do. In my example, I would like to know what the configurations and speeds are of the various addresses interfaces that I have that actually have addresses that are configured for IP. So I needed Ethernet adapters, and I need the network to be enabled on these. I need both conditions to be true to keep it. I'll take the adapters I retrieved in the previous step, run them through my filter, and save them in a filtered adapters variable. Now comes the fun. I can take the filtered adapters variable and pipe it to a loop that goes through every adapter that's in that filtered adapters list. And for each one of them, go find the related configuration. Again, for clarity, as these adapters go through the pipe, inside the for each script, they'll be placed in $_. To make the script more readable, I've taken that and simply assigned the $_ into a variable with a better name, adapter. When I then reach into the adapter as it goes through the pipe and pull out the related configuration, I'm storing that in a network adapter configuration or NAC variable to save typing. Once I've got my 2 objects, the original adapter and the configuration for that adapter, I'm ready to make a new custom object containing only the data that I actually want. So I'll do a new object starting with type ps object, and I'll make my own custom property list. I'd like to keep the name of the adapter from the physical device, so that's the name property in the original adapter. I want the Windows connection name as would show up in the settings window. Again, that will come from the physical adapter property net connection ID. I want the IP address for this, which is going to come from the configuration object property IP address. I want to know if there's a gateway on this adapter, a gateway to other networks. That's going to come from the configuration object property default IP gateway. And I want to know how fast this connection is. That's going to come from the physical adapter property speed, which is in bits per second and therefore hard to read. So I'm going to divide it by 1 million, which then will give me megabits per second, and store it in a custom property name that has parentheses in it, so I need to put it in quotes. I'm going to take the result of this loop and I'm going to store it in my own variable called my network objects, because that's what will come out of here is my own custom objects. I can then take those custom objects and do what I like with them, for example, formatting them out as a nice little table. So that script is here. We can go ahead and try running it to see what it does. Let's assign our network adapters to the adapters variable. If we were to look at it, we would see there indeed are all the adapters, and there's lots of them. We don't want all of them, so our next step is to filter them to reduce the amount of data we're working with. And if we look at the result of that by looking at the filtered adapters variable, we'll see in this particular machine's case, we're down to a single interface. Next, we're going to run those filtered adapters, that list of adapters, through our loop that finds the related configurations and builds new objects using the summary information from the original adapter and the configuration object. And when we look at those ones, we'll actually look at them nice and neat by formatting them into a table. And there's our nice list. If I had 2 adapters in this machine or 6 adapters in this machine, this report would work just fine and generate a list of my configured interfaces with their IP information and speeds.